Welcome to Archaeversity online classes. This lecture is about sign test for two related samples. This is one of the important non-parametric statistical tests where it is applicable on when your data, that is your independent variable, is measured on categorical scale, or that is a nominal scale, and your dependent variable is measured on interval scale or a ratio scale or ordinal scale. In such scenario, we use sign test for two related samples. I'll show you how to calculate sign test for two related samples using IBM SPSS. There are two methods of calculating this in SPSS. I'll show both the calculations with examples. Sign test for two related samples is also called as a paired sample sign test, or just simply called as a sign test, is used to determine whether median difference between paired or matched observations, in the sense there is a median difference, right? The sign test gets its name from the fact that it uses plus sign and a minus signs rather than a quantitative measures. That means if you have a median value here, if it is above a median value, it indicates a plus sign. If it is a below median value, indicates a minus sign. It is particularly useful for research in which quantitative measurement is impossible or feasible, in the sense when your dependent variable is measured on an ordinal scale or a nominal scale. In such scenario, you will not be able to quantify the values, so quantitative measurement is not possible. So in such case, we use a sign test. Next is the sign test is applicable to the cases of two related samples when experimenter wishes to establish two conditions are different. So in these scenarios, we calculate the sign test for two related samples. So the procedure is, most commonly participants are tested at two time points or under two different conditions. Any of these, either it may be considered from one time point to other time point, or two different conditions. When we say that at two time points, maybe once we take a sample in the month of Jan and another time we take a sample in the month of April. So from the same respondents, the samples are collected at two different points. This is one. Or under two different conditions. Maybe take, for example, an individual is given to rate brand A, and he also given to rate a brand B. So two different conditions, because same individual is rating two different products here, and here it is at two different time points. So in these two cases, we use a sign test. Now here two different groups of participants are possible as a matched pairs. Now requirement is that your dependent variable should be measured on a continuous, that is interval or a ratio scale or ordinal scale. When it comes to your independent variable, so independent variable should be two categorical or a related groups. That means your independent variable is on a nominal scale. So dependent variable is on interval or ratio scale, independent variable on nominal scale. The paired observation for each participant to be independent. So this is very important, because the observations should not, in the sense, the observation from one point of a time to another point of time should not get influenced. That is one, and the opinion expressed by one individual should not influence the opinion of other. So they need to be independent. Now assumptions that we make here is that the data should come from a continuous distribution. This is the only assumption for your sign test. Then the hypothesis, null hypothesis, is median difference is 0. Whereas an alternative hypothesis in a one-tailed test, the advanced prediction states that which sign, that is a positive or negative, will occur more frequently. In a two-tailed test, there is which says that two signs occur will be significantly different. So in null hypothesis, there is a no difference. We can say that no difference from a median. Whereas here we have a significant difference, and in a one-tailed test, positives are significantly different from negative values. So here we have two examples. As I told you, there are two procedures to calculate sign test in SPSS. I'll explain both with the two different examples here. A car owner is curious about the effect of oil change on gas mileage. For each of 17 oil changes, he recorded the miles per gallon MPG prior to the oil change and after the oil change. So here you have two conditions, that is a time. So one is a prior and second one is a post oil change. And the data is given to you. I'll show you that in SPSS. So regular oil change obviously crucial to maintain the overall health of the car. It seems to make sense that oil change would improve the gas mileage. Now you have to find out that is there evidence that this is the case, and do the analysis using the sign test. Now the hypothesis that we frame is that the null hypothesis that there is no change in miles per gallon before and after oil change. That is a pre and post oil change. There is no change in a miles per gallon. The alternative hypothesis is that the median of the post oil change miles per gallon has shifted to the right in relation to the pre oil change. So one tail, we are considering one tail here because we are expecting an improvement, so positive side. Now for this we have our data here, miles per gallon data. Here you can see that miles per gallon pre, miles per gallon post. And to analyze sign test, go to menu commands, click on analyze, and here non-parametric tests. So from non-parametric tests, legacy dialogues. In legacy dialogues, two related samples. Why we are taking two related samples is on the same car we got the data for a pre and post oil change. So it is a paired data. That is the reason why two related samples. Then here your pre-sales, set it to variable 1. Then post mileage per gallon, send to variable 2. Uncheck the Wilcoxon. Now check sign test. Go to exact. Then click exact here. Click continue. And then options. Just select the descriptives. Click continue. And then click OK. So the result appears in output document. Here you can see the sample is 17 observations. Descriptive statistics are given here. Frequencies. Negative differences are 5. Positive differences are 12. There are no ties. And the post mileage per gallon significance value is 0.143 for two-tailed. So as your significance value is greater than 0.05, we retain the null hypothesis, indicating that there is no change in miles per gallon before, pre and post oil change. That means oil change has not positive, has not impacted the miles per gallon. Even if you look at a one-tail test also, it is a 0.07, which is again greater than 0.05, which says that, or which suggests us to retain the null hypothesis. This is one example, and we look at the second example. So here in a second example, a new chemotherapy treatment is proposed for patients with breast cancer. Investigators are concerned with the patient's ability to tolerate the treatment, and they measure it on quality of a life and using a rating scale. That is 1 is poor, 2 is a fair, 3 is good, 4 is very good, and 5 is excellent. So this is your, you can say that your nominal interval scale. So each respondent gives you answer either 1, 2, 3, 4, 5, any one they pick. Here you need to test that. The question of interest is whether there is a difference in quality of life after chemotherapy treatment as compared to before. So the hypothesis that we frame here are, null hypothesis is that the median differences is 0, and the alternative hypothesis is that the median difference is not 0. So here difference is 0, that means there is no change, there is no improvement in the quality of a life. And here alternative hypothesis, we say that there is an improvement in a quality of a life. Now for that we have a data here. Here before treatment and after treatment. Then to run your sign test, go to analyze. This time we do with the second option, that is non-parametric test, and here we choose the related samples. So from related samples, in objective, keep this automatically compare observed data to hypothesize it intact. Click on a fields. Now choose your fields. Before, send it to test fields, and after, send it to test fields. Then click on a settings. So here choose custom tests and sign test for 2 samples. Right, and go to test options, verify your significance levels, done. Then click on a run. Now output is in output document here. The beauty is the SPSS will give you the hypothesis test summary, and you can see here null hypothesis that the median difference between before quality of life and after quality of life equals to 0. That means there is no difference, and the test performed is a related samples time test, and the significance value is 0.10, which is much higher than 0.05. So retain the null hypothesis. This is a decision what you have to. Okay, and here are the values before of a quality life and after quality life. Total respondents are 12, test statistics and your standard error, then significance value two-tailed and significance value, exact significance value, and you can see the related frequency distribution charts, related samples. Then you have a before quality of life histogram and after quality of life histogram. So these are the 2 ways to calculate sign test on a paid data. This is how you need to calculate, analyze and test the hypothesis using sign test for 2 related samples using 2 different procedures explained in IBM SPSS. Thank you for listening to the lecture.